The Multiverse Employee Handbook defines nothing as the universe's most successful marketing campaign for something that doesn't exist, yet somehow manages to occupy considerable space in philosophical discussions and cause significant anxiety amongst people who have too much time to think about what isn't there. In practical terms, nothing represents the complete absence of anything, which is considerably more difficult to achieve than most people assume. Rather like trying to find a truly quiet moment in an open-plan office or locating a meeting that actually needs to happen. True nothingness requires not just the absence of matter and energy, but also the absence of space, time, and the possibility of anything ever existing, which makes it the ultimate minimalist achievement. The peculiar thing about nothing is that it refuses to stay put when observed. Quantum mechanics insists that even empty space contains virtual particles popping in and out of existence with the regularity of a particularly unreliable intern, whilst philosophers argue about whether nothing can actually exist, or whether the concept of nothing existing is itself something, thus creating what logic professors call recursive ontological confusion. The handbook notes that nothing has achieved the remarkable feat of being simultaneously the simplest and most complicated concept humans have ever invented, leading to what cognitive scientists describe as conceptual vertigo, and the uncomfortable realization that the absence of everything might paradoxically require the presence of something to define what's absent, which rather defeats the entire purpose of having nothing in the first place. You're tuned into the Multiverse Employee Handbook. Today, we're exploring the science of nothing, using quantum physics, philosophy, and the kind of logic that only makes sense if you're a NASA physicist trying to explain why your research budget disappeared into a literal void. That's right. We're doing a show about nothing. Not in the Seinfeldian sense, but in the science sense. What is nothing? Is it possible to have truly empty space? Can you remove everything, matter, energy, even the laws of physics themselves, and still have something left? As we'll discover, nothing turns out to be surprisingly complicated, rather like trying to schedule a meeting that everyone actually wants to attend, or finding a printer that works when you need it most. But first, gather round the vacuum-sealed conference room, my philosophically perplexed personnel, for a tale that would make even Heisenberg's uncertainty principle file for workers' compensation. In the fluorescent-lit realm of quantum improbability solutions, specifically in the Department of Absence Management, which existed in a superposition of critically important and completely pointless, Senior Void Coordinator Martha Nullworth was having what could charitably be called an existential inventory crisis. It had started, as these things often do, with what seemed like a routine memo from the Interdimensional Efficiency Committee. Subject nothing audit, urgent compliance required. From corporate optimization to all .void specialists. Team. Per the new Cosmic Efficiency Guidelines, Section Null, Subsection Void, all departments must now maintain a minimum nothing index of 47.3% to qualify for interdimensional tax benefits. Please conduct immediate audits of empty conference rooms, excluding those filled with existential dread, unused vacation days, emotional weight, negligible, the space between productive thoughts during meetings, any genuine enthusiasm for quarterly reviews, budget line items that actually make sense. Report all findings using form/01138. Available nowhere. Deadline: yesterday. Accounting for temporal paradoxes. Hashtag productive absence. Hashtag void optimization. Hashtag existential efficiency. Martha stared at her assignment, which was to create a comprehensive inventory of all the nothing in the QIS headquarters. This seemed straightforward enough. After all, how hard could it be to count what wasn't there? She began methodically, starting with conference room Beta 7, which had been empty since the great PowerPoint incident of 2019. But as she entered the room with her nothing detection device, a clipboard with very official-looking checkboxes, she realized the first problem. The room wasn't actually empty. It contained air, for starters. Approximately 25 septillion molecules of it, according to her quantum calculator. Well, Martha muttered, this is going to be more complicated than I thought. She tried the supply closet next, removing every last paperclip, sticky note, and mysterious cable that nobody could identify, but everyone was afraid to throw away. But even then, the space still contained air molecules, electromagnetic fields from the building's wiring, and what appeared to be a persistent smell of despair that defied all known cleaning protocols. That's when the square-haired boss materialized beside her desk, his hair maintaining perfect cubic geometry despite violating several NASA safety protocols. "Nullworth," he announced, his voice carrying the authority of someone who had never actually read the employee handbook, but was confident it supported whatever he was about to say. "I've been reviewing your nothing progress reports, and frankly, I'm disappointed. Your nothing isn't nothing enough." "Sir," Martha replied, "I've removed all the matter I can physically access, but there are still quantum field fluctuations, virtual particles, and excuses, Nullworth. When I was your age, we achieved proper nothingness through sheer determination and adequate project management. Have you tried the industrial strength vacuum?" "Yes, sir. Even with our best equipment, we still have about 10 billion molecules per cubic meter." The square-haired boss frowned, which caused his hair to form concerning geometric angles. "That's not nothing. That's something. Try space, actual space." Martha consulted her research notes. "Well, interplanetary space has about 10 million molecules per cubic meter. Interstellar space drops to 500,000. And intergalactic space, still not nothing," the boss interrupted. "What about that big machine the physicists are always talking about? The one with the hadrons? The Large Hadron Collider Beamline. That's actually the best vacuum in the solar system, sir, but it still contains some particles. Plus, there are quantum fluctuations of the electromagnetic field, 0-point energy." "Nullworth," the boss said, his hair now achieving angles that made nearby geometry textbooks weep. "Let me explain something about corporate efficiency. If we can't achieve proper nothing, how can we expect to achieve proper something? It's basic management theory." Martha spent the next week diving deeper into the physics of nothingness. She learned about Heisenberg's uncertainty principle, which seemed to suggest that the more precisely you tried to define nothing, the more something it became. She discovered virtual particles that popped into existence just long enough to make her nothing measurements meaningless, like temporary employees who appeared just to use the good printer and then vanished. She even consulted with Dr. Pemberton from the Theoretical Physics Division, who explained that achieving true nothingness would require removing not just all matter and energy, but space and time themselves, along with the laws of physics that allowed anything to exist in the first place. "So you're saying," Martha asked, "that nothing can't actually exist?" "Well," Dr. Pemberton replied, adjusting his lab coat nervously, "the moment you describe nothing, you've created a concept, which is something. The moment you measure nothing, you've created an observation. which is something. Even the possibility of nothing existing is itself something. It's what we call recursive ontological confusion. Martha returned to her desk with a new understanding of her impossible task. She opened form/01138 and began typing, "Final nothing audit report. After extensive investigation, I can conclusively report that our nothing index stands at 0%. Every attempt to achieve actual nothingness has resulted in the creation of something, whether it be 1. Measurement apparatus, something. 2. The act of observation, something. 3. The concept of nothingness itself, something. 4. This report documenting the absence of nothing, definitely something. Furthermore, quantum mechanics suggest that true vacuum is actually seething with virtual particles, making it busier than our interdimensional mailroom during tax season. Recommendation: we should rebrand our Department of Absence Management as the Department of Quantum Presence Studies and claim we've discovered that nothing is actually the most fundamental something in the universe. Conclusion: nothing is impossible to achieve, paradoxically making it something we can definitely accomplish by not accomplishing it. Respectfully submitted in a superposition of confusion and clarity, Martha Nulworth, Senior Void Coordinator. The next morning, Martha found a new memo on her desk promoting her to Chief Nothingness Officer, a position that definitely didn't exist but came with excellent non-benefits and a parking space in a quantum superposition of being assigned and unassigned. And that, dear colleagues, is why the Department of Absence Management now has a mission statement that reads, "Successfully failing to achieve nothing since the beginning of time, which may or may not have actually happened." And that brings us to the fascinating science behind nothingness. Unlike the void in corporate mission statements, which are deliberately designed to mean nothing while sounding important, actual nothing follows surprisingly complex rules that would make even the most convoluted organizational chart seem straightforward. You see, what Martha discovered in our tale isn't just bureaucratic incompetence. It's a fundamental feature of reality itself. For over 2,000 years, humans have been trying to figure out what nothing actually is, and we've consistently discovered that it's far more complicated than something. The ancient Greeks started this whole mess. Parmenides, around 500 BCE, argued that nothing cannot exist, because the moment you think about nothing, you've created a thought, which is definitely something. It's like trying to not think about elephants. The instant someone tells you not to think about elephants, you're thinking about elephants. Except with nothing, you're thinking about not elephants, which is still thinking about something. Aristotle took a different approach and declared that nature abhors a vacuum, which became the scientific equivalent of saying, the universe really doesn't want you to succeed at this particular project. For over 1,000 years, this seemed reasonable enough. Every time someone tried to create empty space, air rushed in to fill it, like middle managers rushing to fill any meeting that might actually accomplish something. But then came the 17th century, and scientists like Torricelli and Pascal figured out how to trick nature into creating measurable empty spaces. They discovered that air has weight. We're living at the bottom of an ocean of atmosphere, which explains why everything feels so pressurized, especially during quarterly reviews. This seemed like progress until quantum mechanics arrived in the 20th century and ruined everything by being accurate. No! Heisenberg's uncertainty principle revealed that even if you somehow removed every last particle from a region of space, The vacuum itself would still be seething with virtual particles. Pairs of matter and antimatter that pop into existence just long enough to make philosophers question their career choices, then annihilate each other and disappear. It turns out that truly empty space is busier than a startup's Slack channel during a product launch. The quantum vacuum has measurable energy, which means that the closest thing to nothing we can achieve is still definitely something. It's just something that's very good at pretending to be nothing, like most corporate synergy initiatives. When we return from this brief quantum fluctuation, we'll dive deeper into the specific levels of nothingness that scientists have managed to achieve, and explore why creating true nothingness is harder than finding meaningful work in middle management, which, as we all know, approaches the theoretical limits of impossibility.
Nothing.
Welcome back, my existentially questioning colleagues. Now that we've established that nothing is surprisingly difficult to achieve, rather like getting unanimous agreement on a lunch order, let's explore how humanity has been failing spectacularly at creating nothingness for over 2 millennia. Ancient philosophy, the original nothing problem. Our story begins with Parmenides of Elea, around 500 BCE, who had what might be called the first recorded philosophical panic attack about nothingness.
No.
Parmenides argued that nothing cannot exist, because, and this is where it gets deliciously circular, if nothing existed, it would be something, which means it wouldn't be nothing. His logic was ironclad. To even think about nothing, you must have a thought, and thoughts are definitely something. Therefore, nothing thinking about nothing can exist without creating something. This is what philosophers call a recursive ontological contradiction, and what the rest of us call why I switched my major from philosophy to accounting. Aristotle, being Aristotle, decided this was all too abstract and declared that nature abhors a vacuum, horror vacui, which became physics' equivalent of the universe has strong opinions about your life choices. For over 1,000 years, this seemed perfectly reasonable. Every time someone tried to create empty space, air rushed in to fill it, like how middle managers rush to fill any silence in a meeting with unnecessary commentary. But Aristotle's rule had an unspoken corollary. Nature abhors a vacuum like HR abhors efficiency. It will go to extraordinary lengths to prevent it. But occasionally, despite everyone's best efforts, it happens anyway. Fast forward to 1643, when Italian physicist Evangelista Torricelli created what was essentially the world's first successful nothing, though he didn't realize it at the time. Torricelli's barometer involved filling a glass tube with mercury, flipping it upside down into a dish of mercury, and watching as the mercury level dropped, leaving a space at the top that contained, well, that was the question. Torricelli had created the first measurable vacuum, though it still contained mercury vapor and probably some lingering existential anxiety. More importantly, he discovered that air has weight, about 14.7 pounds per square inch at sea level, which means that right now you're being pressed down on by roughly the weight of a small elephant distributed across your body. You're welcome for that mental image. Blaise Pascal took this further, literally. He carried mercury barometers up mountains and discovered that air pressure decreases with altitude. This led to the revolutionary realization that Earth is wrapped in a thin shell of atmosphere, beyond which lies the vast emptiness of space. We live at the bottom of an ocean of air, which explains why everything feels so pressurized, especially during annual performance reviews. The universe's default setting, it turned out, wasn't the cozy fullness that Aristotle had imagined, but rather an infinite expanse of cold, silent void, punctuated by tiny islands of matter. This was rather like discovering that your comfortable office building is actually a small bubble in an enormous airless warehouse that goes on forever in all directions. But science abhors a conceptual vacuum almost as much as nature abhors a physical one. By the 19th century, scientists faced a new problem. Light clearly travels through empty space. We can see the stars, after all. But light was understood to be a wave, and waves need something to wave in. Sound waves travel through air. Water waves travel through water, so light waves must travel through... What? Enter the luminiferous ether, one of science's most elaborate attempts to fill nothing with something invisible. The ether was imagined as an invisible, massless, frictionless medium that filled all of space, providing light waves with something to wave through. It was like cosmic bubble wrap, everywhere, invisible, and supposedly essential for the proper functioning of the universe. James Clerk Maxwell loved this idea because it gave his electromagnetic equations something concrete to describe. Isaac Newton had proposed something similar centuries earlier. The ether was the perfect solution. It filled all of space, solving the wave problem while being completely undetectable, solving the "why can't we feel it" problem. This worked beautifully until Albert Michelson and Edward Morley decided to actually test for the ether's existence in 1887. Their experiment was ingeniously simple. If Earth is moving through a stationary ether, then light should travel at different speeds, depending on whether it's moving with or against our planet's motion through this cosmic medium. They built an extraordinarily sensitive interferometer, basically a device that could detect minute differences in light travel times and measured light beams traveling in different directions. According to ether theory, they should have found clear differences in light speed. Instead, they found nothing. No matter which direction they pointed their apparatus, light traveled at exactly the same speed. This was rather like discovering that no matter how fast you drive, your speedometer always reads the same number. Either their equipment was fundamentally flawed, or the ether simply didn't exist. After years of increasingly desperate attempts to explain away their results, the scientific community eventually accepted the obvious conclusion. There is no ether. Light travels through genuinely empty space, carrying its own electromagnetic waves without needing any medium to wave through. Einstein's special relativity finally provided the theoretical framework for this reality in 1905. Demonstrating that light doesn't need anything to travel through. It simply travels at a constant speed through whatever space happens to be available, empty or otherwise. And so, after centuries of insisting that nothing couldn't exist, science had accidentally proven that nothing could indeed be nothing, at least at the classical level. Just when scientists thought they'd finally achieved proper nothingness by eliminating the ether, along came quantum mechanics in the early 20th century to ruin everything with inconvenient accuracy. Well, that was subtle, wasn't it? I do hope the explosions added a much-needed nuance to our discussion of nothingness, because nothing quite underscores the elegance of theoretical physics, like being audibly shelled into comprehension. Still, if you insist on deafening the audience, do carry on. I'm sure the Higgs boson heard every word.
Sorry about that. Won't happen again.
Thank you. Now, where was I? Quantum physics looked at the beautiful emptiness that classical physics had created and said, "Hold my coffee. This is about to get weird." The trouble started with Werner Heisenberg's uncertainty principle in 1927. Most people know this as you can't simultaneously know a particle's position and momentum with perfect precision. But Heisenberg discovered something even more unsettling. The principle also applies to energy and time. Here's where it gets cosmically bureaucratic. If you examine any region of space for a brief enough period, the uncertainty principle says you can't know exactly how much energy is in that region. And here's the kicker. If you're uncertain enough about the energy content, there's actually a chance that region could temporarily contain enough energy to create particles literally out of nowhere. Think of it as the universe's equivalent of floating a check. You can borrow energy from the cosmic bank account, but you have to pay it back so quickly that the cosmic auditors don't notice. These borrowed particles are called virtual particles, and they pop into existence in pairs. A particle and its antimatter twin exist for a tiny fraction of a second, then annihilate each other and pay back the energy debt. This means that what we call empty space is actually seething with virtual particles appearing and disappearing like temporary employees who show up just long enough to use the good printer, raid the supply closet, and vanish before anyone can assign them actual work. But here's the truly bizarre part. This isn't just theoretical speculation. These virtual particles have measurable effects. They create what's called zero-point energy. Even completely empty space has a baseline energy content that's greater than zero. It's as if the universe charges rent for existing, even when no one's home. Willis Lamb proved this experimentally in 1947 by showing that virtual particles cause minute shifts in electron energy levels within atoms. The effect is tiny, like measuring whether a single grain of sand affects the flight path of a jumbo jet. But it's measurable, and the theoretical predictions match experimental results to extraordinary precision. So, if quantum vacuum isn't actually empty, what about the nothing we can create with technology? As Neil deGrasse Tyson has pointed out, there's actually a hierarchy of nothingness, each level representing our increasingly desperate attempts to achieve true emptiness. Side note, I recommend checking out the Star Talk episode Neil deGrasse Tyson Explains Nothing for Neil and Chuck's hilarious banter about nothing, which is definitely something.
There you have it. If you don't like science after this shit...
So, let's start with your average empty room, which contains about 25 septillion air molecules per cubic meter, more molecules than there are stars in the observable universe, all bouncing around in the space you casually call empty. The best laboratory vacuums can pump this down to about 10 billion molecules per cubic meter. This sounds impressive until you realize that's still 10 billion molecules busily doing molecular things in what you're calling a vacuum. It's like claiming your house is clean because you've reduced the dust from completely covered to merely significantly dusty. If we venture into space, interplanetary vacuum contains roughly 10 million molecules per cubic meter, 1,000 times better than our best laboratory efforts. But space is vast and patient, so it has advantages we don't. Interstellar space, the void between stars, drops to about 500,000 particles per cubic meter. This is the kind of emptiness that makes laboratory scientists weep with envy, yet it's still undeniably something rather than nothing. The most rarefied natural vacuum is intergalactic space, the enormous voids between galaxy clusters, which contains only a few atoms per 10 cubic meters. This approaches true nothingness in any practical sense, except for the minor detail that it still contains atoms. Remarkably, The best vacuum ever created is not in the depths of space, but right here on Earth, in the beamlines of the Large Hadron Collider. CERN's particle accelerator requires such extreme vacuum that they've created emptier space than exists anywhere in the solar system. So empty that stray particles would interfere with their attempts to smash other particles together at nearly the speed of light. Yet even this ultimate technological achievement still contains quantum field fluctuations, virtual particles, and zero-point energy. The best nothing humanity can create is still definitely something. This brings us to what might be called the recursive description paradox. The moment you describe nothing, you've created a concept, which is something. The moment you measure nothing, you've created an observation, which is something. Even the possibility of nothing existing is itself a possibility, which is conceptually something. Tyson's hierarchy of nothingness illustrates this beautifully. You can systematically remove matter, then energy, then electromagnetic fields, then space and time themselves, then the laws of physics that govern reality. But the moment you describe this process, you've created a framework for understanding it, which brings something back into existence. This leads to what philosophers call the difference between cosmological nothing and absolute nothing. Cosmological nothing is what physicists mean when they discuss the universe emerging from nothing. It's a quantum vacuum state, rich with virtual particles and governed by physical laws. It's nothing in the sense that it contains no classical matter or energy, but it's definitely something in terms of having structure, properties, and potential. Absolute nothing would be the complete absence of everything. No matter, no energy, no space, no time, no laws of physics, no possibilities, and crucially, no framework for describing or understanding this absence. This kind of nothing may be logically incoherent, since describing it seems to create the very conceptual framework it denies. The universe emerging from quantum vacuum makes sense scientifically. It's governed by physical laws and follows mathematical principles we can understand. The universe emerging from absolute philosophical nothing would require something that doesn't exist to create something that does exist, which violates more logical principles than a corporate reorganization chart. And so we arrive at the profound irony of nothing. The harder we try to achieve it, the more something we create in the process. Nothing, it turns out, is the most productive thing the universe has ever invented. It's been so successful at not existing that it's created everything that does exist, including us, and including our seemingly endless capacity to be confused by this entire situation. Well, my cosmically insignificant colleagues, we've reached the end of another quantum expedition into meaninglessness. Today, we've learned that in the multiverse of nothingness, every void exists in a superposition of completely empty and surprisingly full of virtual particles. We've discovered that nothing is far more complicated than something. Rather, like how a simple request to fix the printer inevitably requires 3 IT specialists, 2 different software updates, and a theological discussion about whether the printer actually wants to be fixed. From Parmenides' ancient logical loops to Heisenberg's uncertainty-powered particle factories, nothing has consistently refused to cooperate with our attempts to understand it. We've seen that achieving true nothingness is harder than finding meaningful work in middle management, and considerably more expensive than most corporate team-building exercises. Even the universe's best efforts at creating emptiness, those vast intergalactic voids that stretch for millions of light-years, still contain enough atoms to make philosophers question their career choices. Perhaps most remarkably, we've learned that the quantum vacuum, our closest approximation to nothing, is actually seething with more activity than a startup's ping-pong table during crunch time. Virtual particles pop in and out of existence with the regularity of urgent email requests that turn out to be anything but urgent, creating zero-point energy that proves even empty space charges rent for existing. Though I suspect somewhere in the quantum foam of reality, there's a universe where nothing actually manages to be nothing. And a corporation like Quantum Improbability Solutions has developed a cost-effective method for achieving true philosophical void, probably by implementing it as a mandatory employee wellness initiative. Want to explore more quantum corporate chaos? Visit us at multiverseemployeehandbook.com, where you'll find fascinating science news, deep dives into the physics of nothingness, and our latest blog series, Filling Out Forms in the Void, a guide to productive nothingness. And if you've enjoyed today's existentially bewildering adventure, why not share it with a fellow philosophically perplexed colleague? Perhaps you know someone who's been struggling with the recursive paradox of describing indescribable absence, or who simply needs to understand why their attempts at achieving inbox zero keep creating new emails. Spread our signal like virtual particles in a quantum vacuum, briefly, inexplicably, and with questionable practical value. This is your quantum coherent correspondent, reminding you that in the multiverse of nothingness, we're all just temporary fluctuations in the cosmic vacuum, filing reports that may or may not exist in realities that definitely need better documentation standards. Remember, according to Martha Nullworth's final report, this episode simultaneously happened and didn't happen until you rated it. So please collapse your listening experience into a positive review, preferably one that exists.
Hello?
Hey, I'm Rob Corrigan, the human who dreamt up the Multiverse Employee Handbook, because I can't stop marveling at how strange and wonderful the universe is, and how often it behaves like a very large company with confusing corporate policies. In a world increasingly run by AI, I think it matters to be clear about what's human-made and what's conjured by machine magic. So here's the straight-up rundown. The host, David, is a professional voice actor. The voice you hear has been digitized using ElevenLabs voice cloning technology, with his blessing and excellent enunciation. The episode thumbnails are created with OpenArt's AI models. Music and sound effects come from Pixabay, composed by human artists. Everything else, the writing, the jokes, the research, is 100% me, human hands, human brain, and occasional human muttering. Thanks for listening, and for being a good human in an increasingly automated cosmos. And if you like this show and make it this far, it would really mean a lot to me if you shared it with a colleague, a friend, or anyone. It's really the best way to make podcasts like this grow, and I sincerely appreciate it.
Rob, do stop ringing after hours. The kettle's on and I'm halfway through a biscuit. Toodaloo.